It's called solving right triangles. There's a couple different things in here. Okay, one of the things is the term solving a right triangle. On that first page, there's some different vocabulary. We've talked about angle of elevation and angle of depression, but there's a couple pictures there that you can look at to see, right? Angle of elevation and angle of depression. Not that that's the focus of this section, but those are two terms to be able to interpret some of the problems. It helps to understand that. The angle measured up from the horizontal or down from the horizontal. Always from the horizontal. The other term in here that we're going to look at first is solving a triangle. Solving a triangle just means finding all the unknown things in that triangle. For now, all we're doing this year is right triangles. Later on in grade 11, you might look at non-right triangles. You might look at triangles like that and use trig to find the angles and stuff. But for what we're doing, you're doing just right triangles. So if we were to draw some kind of a right triangle here that looks like this, and we need one other line here, of course. So there's our right triangle. There's a right angle. If we don't know anything about that, right now all we know is one angle. You need more than one angle. You need the right angle and two other things. If you know the right angle and two other things. In other words, if you know three things about a triangle, you can figure out everything about it. Okay, you need three. I'm going to use the word things, meaning a side or an angle, to be able to solve it. Okay, so you need three things. In this, let's say we have, there's different situations you could have. You could have, and one of them has to be a side. You can't have just the angles, right? If we had just the angles, then this could be, this could be bigger or smaller, and you can't actually solve it. You need three things, and one of those things has to be a side. So you could have a side and an angle, right, like this. You could say that this was 20, and that, say, this angle here was 18 degrees. That could be one way it could be, right? In that case, what things are missing here? Let's say this was called A, and this was called B, and this was called C. Let's say, just to make it easier, that you had those things labeled. What's missing on there? What things are missing? I will highlight them for you. Are there any angles missing? You know this one, but you don't know this one, right? You don't know angle B there. You need to find angle B. What else do you need to find? The hypotenuse, right? Now, partly in labeling this, you know that if you have a B on one end of the line and an A on the other end of the line, you could call that side, you could call it AB. But I know some people get troubled when they write trig equations and they put AB in there. So what you could call this side here, what they do is if you have the corners, the vertices that have letters, you can name this the same letter as the opposite side, but a lowercase letter. So they will call this small letter C. And then this side's unknown as well. What would that be called? The one across from it, that would be called small letter A. That's one way of doing it, but you can call them A, B, and B, C if you want. I'm going to use those small letters there. So you need to find three things here. You need to find angle B, you need to find side A, and you need to find side C. That's what it means to solve a triangle, to find all those missing things. Which one of those things is going to be the easiest to find? What do you think? Angle B is the easiest in this case. You may have learned that something about a triangle, about what the angles add up to. What do the angles in a triangle add up to? What do they add up to? 180, right? You got to use the fact that I'm going to put the angle sum of a triangle is 180 degrees. So if you know that you have the whole thing adds up to 180 degrees, we can find angle B by just subtracting, right? 180 minus this, right? which is how much? 90 minus this, right? Minus the other 2, minus 18. And that gives you what? 72 or something? 72. You could also get really clever, I guess, and say, if it's a right angle triangle, there's always going to be a right angle, right? It's a right angle triangle. And if that's 90, what do the other two angles have to add up to? They have to add up to 90 as well, right? So you could just say that the other angle is 90 minus this, right? You could do that just to make it a bit quicker if you want. You could say, you could do it this way. You could say angle B is 90 minus 18. 90 minus the other one, 72 degrees. That's quicker, right? Because they're always the two non-right angles are always going to add up to 90. So there, you already found one of the things. Solving a triangle is not as hard as you think. Finding the other two sides might be a bit tougher, right? Because before, when I showed you a triangle and said find the missing thing, you only had 2 pieces of information and 1 variable, right? So it would look more like this. All of this stuff would be gone, right? Because there you have 2 sides, or an angle and a side, and then a missing one. But now it looks like there's variables all over the place. You have to just zero in on the one you want to find and the 2 you know, and then use those things. Then just ignore everything else. The one you want to find and the 2 you have, and label the triangle from the point of view of that angle, and then set up a trig equation. Because to find a side, if you already have another side and an angle, you can use trig, right? You can write a trig equation. Which ratio would you use if these are the 2 sides involved? That's the opposite. That's not the hypotenuse. What is that? Adjacent. So again, you're gonna. I know I've showed you this a million times, but make sure you have this handy if you don't have it in your head. That you got the opposite and the adjacent, so it's this one, right? So if you're doing that, basically you're starting from that and then working from there, writing an equation from that. If you want, you could write tan is opposite over adjacent. You could write that if it helps you structure the equation properly. Tangent of 18. Which way does this go here? A over 20, right? And I think we're probably getting quick enough at this that we realize this 20 can just go over there, right? Multiply it on the other side. Okay, if you times both sides by 20, the 20 ends up on the other side. A is 20 times tangent of 18. You work out what the tangent of 18 is and then multiply it by 20. Can somebody do that on the calculator? Unless you have a table of trig values stored inside your brain somewhere. What does that give you? 6 point something? 6.49. Okay, well if we're doing 2 decimals, is that rounded to 49? So 6.4, what was it, 49 something? 498. If it's 498, then we got to think about how we're rounding this. If we want to do this to 2 decimal places, it's tough to think about. That 8's going to round that, right? But it's a 9 already, so what do you round it to? It's a 0. Now, I know that you probably want to put this, but you actually, if you want to say it to 2 decimal places, you put a 0 there. Putting a 0 there is different than just saying this. This is saying all of the only accuracy I went to is 1 decimal, and it's a 5. Putting a 0 there is saying I looked at 2 decimal places, it's 50, it's more accurate. So if you're asked to do 2 decimals, that's what you have to put. It doesn't say anything here, but that's the length of that side. Now to find the third side, you have a couple of options here. You have a couple of options. Now you don't only have the 2 things that were given, but you have 2 other things. You have lots of stuff now, right? You have everything except for that side. So how are you going to find the other side? What ways could you do it? What could you do? You could do adjacent over hypotenuse. and use cosine, or you could use opposite over hypotenuse and then use this value that you found here. I would say that probably one of those is a better option than the other. Do you think it's safer or better to use this involving the one that you're given, or this and using the one you just figured out? The one you're given is always going to be safer because you may have gotten this wrong is one of the reasons. But also, if you round this off and then you use it to calculate another thing, what's going to happen? It's going to be less accurate. We don't want you to be the future bridge builders of the world if you do that, because then your bridges are going to fall down. We're all going to die, fall into the river, right? If you're an engineer, you can't use rounded off values to calculate more stuff. So it's better to use given values. If you really want to use this, use all the decimal places on your calculator and you can preserve a bunch of accuracy. There is a third way you could find it if you don't mind using this value. You have two sides now. If you have two sides of a triangle, what's another way you could find the third side? Yeah, you could use Pythagoras if you want. So you could, I'm going to put here, I'm going to do it the trig way, but you could also use Pythagoras. Pythagoras. Okay? I'm going to use the trig way, but you could also use Pythagoras there to find it. Right? You could do a squared plus b squared equals c squared in this case. I'm going to use these two sides. Which trig ratio do I need to use for those two sides? Cosine, right? You have adjacent, you're wanting the hypotenuse. So we want to do cosine of 18 is 20 over c. Now this one is the one that when you have your variable in the bottom of your ratio, when the variable's on the bottom of your ratio, how do you go about solving that? What do you think? Yeah, you switch this cos 18 and c. If you're doing it in one step at a time, you put that up there, and you put this down here. Now, it isn't just randomly moving stuff around. If you have something divided on one side, it's the same as multiplying on the other side. Dividing by c on one side is the same as if you change that to multiplying by c on the other side. Now, if you just scribble things out and move them, I can't see when I look at your work that you've done that. So it's better if you actually write each step. You don't have to show that step. If you can see right away that it's going to be 20 divided by cos 18, you don't need to put this step if you don't want to. If it helps to get it right, put it down, but you really only need to jump from there to there if you want. And then we can work it out on calculator. Anybody able to do it? Point what? 21.02? What's the number after the 2? It's 03? Okay, good. Now you look back and you say, does that seem reasonable? Do you expect this is a little bit longer than that 20? Yeah, you expect it to be, it's got to be longer. It's not a very big angle here, so it's not going to be tons longer, but. Okay, so that's finding all three of those things. Now you have all the pieces of the triangle. You have the three that you were given, right? You were given 90 degrees and those two things, and you found the other ones. Okay, so that's what's called solving a triangle, finding all the missing stuff. We could design different triangles where this angle was up up on top here, right? Where this angle's up there. We could have it where you have two sides and no angles. If you have two sides and no angles, you'd have to think about how to find it, because it wouldn't be so easy to find one of the angles. You couldn't just use subtracting from 90. You'd have to actually use, what would you have to use then if you didn't have either of those two angles? You'd have to use one of the inverse functions, sine inverse, cos inverse, one of those to find one of the angles and work from there. Okay? So that's what's called solving a triangle.